Hello, ladies and gentlemen of Algebra 2B. Today we are going to build on our yesterday discussion of exponents by looking at rational exponents. Now, don't be worried about that word. In a math class, rational simply means fractional. And we know that one way to write fractions is in the form a over b. You can sometimes see them be written in this format. So both of those would be ways to write ratios, and rational is the adjective form of ratio. So rational and fractional mean the same thing. So look, we're going to look at x to the a over b power right here. So I have a fractional or a rational exponent. And so you need to know that the denominator b goes as part of the index of the radical, and the top part, the a, becomes the exponent. And we're going to work on how you write those, convert back and forth easily from fractional exponent form to radical form. So you have lots of different radicals. We don't normally say radical x. You need to say the symbol is the radical. But we need to call them square roots or cube roots or fourth roots or fifth roots. And then whatever you're taking the square root or cube root or fourth root of is what's under the radical, and we call that the radicand. Okay, enough vocabulary. Now what we're going to work on this first page is simply converting from rational exponent form to radical form. So in this one, we're going to say, well, we have a radical, and we put a underneath. Now remember, the 1 on top becomes the exponent. The 2 on the bottom becomes the index of the radical. Well, two things. If you mean, because what you've said right here is square root, if you mean square root, we generally do not put the little 2 in the little hook of the radical. So, and we also don't generally say a to the first, we just say a. So a to the 1/2 is the square root of a. But on the second one, we're going to put b under the radical, and the 1 on top is the exponent, and the 3 on the bottom of the fraction does go into the little hook of the radical. So on this one, we would call this the cube root of b. We're normally not going to say b to the first. Now on the next one, we're going to set up our radical, and we're going to say, so it's c. Now, the 2 becomes the exponent because it's on the top. The 3 becomes the index of the radical because it's on the bottom. Now, you might also see this written as the cube root of c all squared. You can write it either way. I usually write it the first way, but sometimes I'll actually think about it the second way. But either way is fine when you write it. So on this one, I've got radical sign, d. Now, this time, the exponent is 3. I'll write that where I meant to write it. And the index of the radical is 2. But remember, if the index of the radical is 2, that's a square root. So we tend to just say the square root of d cubed. Or you could say the square root of d all cubed. And sometimes that's a helpful way to think about it. So let's look at learning your powers, because we're fixing to use this rewrite process in order to evaluate some things without calculators. Well, if you're going to evaluate without calculators, you need to know your powers. So we need to know, for instance, that 2 to the first is 2, 2 squared is 4, 2 to the third is 8, so I'm just multiplying by 2 over and over again. So 8 times 2 is 16, so that's 2 to the fourth. 16 times 2 is 32, so that's 2 to the 5th. And then 32 times 2 is 64, so that's 2 to the 6th. Now, when your base is little, like 2 and 3, then I'll ask you to know bigger powers. But as our bases get big, I won't ask you to know such large powers. So I know that 3 to the first is 3. 3 squared is 9. 9 times 3 is 27, so 3 cubed is 27. 27 times 3 is 81. So 3 to the fourth is 81. 81 times 3 is 243. So 3 to the fifth is 243. And 243, if you do this on your calculator, times 3, you're going to get 729. So 3 to the sixth is 729. So yes, you're going to have to do a little memorization, but if you are making your chart, then just the sheer process of writing begins to start that memorizing process. Now 4 to the first is 4, but 4 squared is 16. 16 times 4 is 64, so 4 to the third is 64. And then if I say 64 times 4, I get 256, so 4 to the fourth is 256. But guys, that's probably as big as I would ask you to go on something like that. So see, we're already about starting to drop off on how big a numbers you need to memorize. So 5 squared is 25. 25 times 5 is 125. That means 5 cubed is 125. 125 times another 5 is 625. So that means that 5 to the fourth is 625. All right, 6 squared is 36. 36 times 6 is 216. So usually when we get to this level, I'm just going to ask you to know your perfect squares and your perfect cubes, okay? So 7 squared is 49. 49 times another 7 is 343. So 7 to the third is 343. 8 squared is 64. And if I say, well, what is 64 times 8? I get 512. So 8 cubed is 512. 9 squared is 81. And then 81 times another 9 is 729. So 9 cubed is 729. Hey, is it a coincidence that 729 is 9 to the third? Oh, nope. Let's try that again. And 729 is also 3 to the sixth. No, it's not. Because, guys, if I say, well, let's look at 9 cubed. Now, do you know that we can rewrite 9 as 3 squared? Of course you do. Now, what's the rule when you do power to a power? So, do you see that what I would have to do is say, oh, 2 times 3 is 6. Well, that's why 9 to the third and 3 to the sixth are both 729. It's just a simple use of exponents. Now on the tens I can go forever. 10 to the first has 1 0. 10 to the second has 2 zeros. That's not really where I meant to write that. 10 to the third has 3 zeros. 10 to the fourth has 4 zeros. 10 to the fifth has 5 zeros. And of course 10 to the sixth has 6 zeros. So you can do the powers of 10 forever, all right? But this is a good chart for you to begin your memorization because most of this kind of thing will be a no calculator thing. So what I want to do is I want to rewrite these in the radical form in order to evaluate. So on the first one, do you recognize that 8 to the 1/3 is the same thing as the cube root of 8? And on the second one, 9 to the 1/2 is the square root of 9. Now I'll stop here and we'll evaluate. So on the cube root of 8, you have to go, oh, wait a minute. If 2 to the third equals 8, then that means that the cube root of 8 equals 2. So use the power chart that we just did. Oh, and I just realized, you probably thought I'd lost my marbles. I said the square root of 9, I think, and I wrote the square root of 2. So I'm glad I caught that just now. What is the square root of 9? 3, of course. Sorry about that, guys. Now, on the next two, look at where the negative is and the parentheses. This is important. We need to make sure you know that there is a difference in the way you write the problem, the way you think of the problem. So on the third one, this is the cube root of negative 27. So what number do I multiply by itself 3 times in a row and get negative 27? Well, the answer is negative 3. Because think about it, negative 3 times negative 3 times negative 3. That's an odd number of negatives. So you know it's going to turn out negative. And 3 times 3 times 3 is 27. So the cube root of negative 27 is negative 3. Now on the next one, I need to realize that if the negative is not already in parentheses, then interpret it like this. It's actually the problem negative 1 times 64 to the 1/2 power. So if the negative is not grouped in the parentheses like it was on problem 3, then you're not taking the square root of a negative number, you're taking the square root of a number and multiplying by -1. So we need to make sure you're okay with that. So this is -1 times the square root of 64. So do you see that that would be -8? Let's keep going with these. I think these are fun once you know what the rules of the road are. So on this one, guys, you're going to say, okay, now wait a minute. I'm taking the square root. I see that part. And then I've got 25 over 49, but it's still to the -1 power. Well, do you remember that negative exponents, like if it's a to the -1 power, remember that means you make it 1 over a. Or if it's 1 over b to the -1 power, that means you can move the b up to the top with a +1. But do you remember the rule that if you've got c over d to the -1 power, that just means that you can flip it and make it d over c. Because then you would have c to the -1, which drops to the bottom, and then d to the -1, which raises to the top. So that means on this one, I'm really wanting you to take the square root of 49 over 25. I'm going to flip the 25 over 49 because it's raised to the -1 power. Now, how do you do that? Well, I take the square root of 49, and then I take the square root of 25. All right, so not bad. None of these are real bad. You just have to understand how to write them down in a user-friendly way that helps guide you through the thinking process. So on the next one, I see again that it's the cube root of 125, but the 125 is to the -1 power. Well, that means the cube root of, you need to make 125 to the -1, 1 over 125. So now I've got to do the cube root of 1, which is just 1. And you might go, why? Because 1 times 1 times 1 equals 1, right? And then what is the cube root of 125? Do you recognize from your power chart that we created that it's 5? So, same thing on the next one. I need to make this the square root of 100 to the -1 power. So that means the square root of 1 over 100, and that is, you're right, 1/10. Way to go, you. Now on the next one, 4 to the 3/2 power, well, that means the square root of 4 cubed. So guys, on this one, you've got two choices. You're allowed to do the square root first, or you're allowed to do 4 to the 3rd first. So you can do either one. You can manage without a calculator. So if I said, well, I'm going to do the square root first, then I would say the square root of 4 is 2. And then I would still have 2 to the 3rd, and 2 to the 3rd is 8. But you're also allowed to say, no, I want to do 4 to the 3rd power first. So 4 to the 3rd power is 64, but now I want to do the square root second, and then that's 8. And so you can go either way. I always tell students, figure out which one you can do without a calculator and do it first, whichever one it is. So on 16 to the -3/2 power, so I know that's the square root of 16 to the -3rd. All right, so that's the square root of 1 over 16 to the 3rd. So instead of saying 1 over 16 all to the 3rd, I'm just going to say the 3rds on the bottom. It's the same thing. So guys, look at what I just said if you didn't understand. I can say 1 over 16 all to the 3rd, but that's the same thing as saying 1 over 16 to the 3rd, because 1 to the 3rd on the top is 1. So you can write that either way you want to. So I know that the square root, 16 to the 3rd is too big. We didn't have to put that in our power chart. So usually I'm going to try to bring the numbers smaller before I go bigger. So I'm going to try to do the square root part first. Well, the square root of 1 is 1. The square root of the 16 on the bottom is 4. Now I'm going to have to deal with the to the 3rd power part. So that's 1 over 64. Typically, it's a little faster to do the root part first because it makes the number smaller, and do the power part second because it makes the number larger. So on the next problem, again, you've got the cube root, I see, and it's going to be 343 over 8 all squared. Well, guys, I can do 8 squared, but I cannot do 343 squared. I don't have that memorized. It's way too big. So I'm not going to do the squared part first. I'm going to do the cube root part first. Well, what is the cube root of 343? If you said 7, you're correct. What's the cube root of 8? If you said 2, you're correct. But now I've still got to do the squared part. So 7 squared on the top, 2 squared on the bottom, and I am done. I think these are fun. I think they look more gruesome than they are. So 216 to the 2/3 power. Well, that means the cube root of 216 squared. Now, it's the same situation. I can do 216 squared first, but it's too big. I don't know that number. And I'm trying to do these without calculators. So go small first. Do you know the cube root of 216? If you said 6, you're right. So I do the cube root first, but I'm still on the hook for squaring this puppy. So I've got 6 squared is 36, and it's all okay. I can do that. Now on the next one, I can see it's the cube root of 27 to the -2 power. All right, I'm not going to deal with the negatives, so that means I've got to write it as the cube root of 1 over 27 squared. And again, I could write the 1 over 27 in parentheses and square it all, but I like just taking the squared part with the number, not with the whole fraction. You could do either way. So again, I'm going to do the cube root part first because it makes my numbers smaller. So the cube root of 1 is 1. The cube root of the 27 is 3, but I've still got a square. So I'm going to get 1/9. I hope you're doing okay out there in at-home digital world. All right, so last few. So look, I've got negatives on the first ones, and I want to remind you, if it said, for instance, -64 to the 1/6, it would mean I was doing the 6th root of -64. All right, that's not what number 13 says. If the negative is not in parentheses, then imagine that it's negative and then parentheses on both of these, okay? Because the negative is not in parentheses. So that means we're going to imagine that this is -1 times 64 to the 1/6, which is -1 times the 6th root of 64. Do you all see that that's -1 times 2, which is -2? So I'm going to imagine that this is -1 times 8 to the -7/3. So that's -1 times, I'm going to have to do the cube root of 8 to the -7th power, okay? Well, you can go ahead and do the cube root part if you want. What's the cube root of 8? 2. And then just do 2 to the -7th power. So that would be -1 times 1 over 2 to the 7th power. Okay, so the fraction's going to wind up negative, and 2 to the 7th. Now, wait a minute. You know your powers. 2 to the 6th is 64. So are you with me that 2 to the 7th is going to be 64 times 1 more 2? So that's 128. Okay, that's not one that I memorized, but that's one I can figure out without a calculator because it's generally pretty fast to double numbers. You could probably double your numbers for quite a long time without having to use a calculator. Now on the last one, I'm going to worry about that big -1 on the outside at the end. But you could actually do this 2 different ways. All right, so what I was saying is that I'm going to say, let me do the 4th root of 81 to the 5th. So I'm going to worry about the inside and then put the -1 to the outside, and I'm just going to leave it to the outside. Well, I certainly don't know 81 to the 5th. I don't even know what 81 squared is by heart. But I can do the 4th root of 81, and that's 3. But I still haven't done the 5th power part, so I need to do this. Well, I know that the 3 to the 5th is 243. Now I've got 243, and I still have to deal with the -1 part, so it's 1 over 243. Okay? Now, you could have also handled it differently. You could have said, look, whenever you have power to a power, you multiply the powers. So 5/4 times -1 is -5/4. Then you could have said that was the 4th root of 81 to the -5th. You still could have said, well, the 4th root of 81 is 3. So I've got 3 to the -5th. Well, that means 1 over 3 to the 5th. Oh, so that still means 1 over 243. So with these guys, just because I have a certain habit about the order I go in, it doesn't mean all the time that that is the only way to go. It's just the way that has made sense to me, and I've developed good habits that way. All right, so now we're going to go the other direction. We're going to go from radical form back to the fractional exponent form. Or you might say back to the rational exponent form, because remember, fractional and rational mean the same thing in a math class. So remember, the understood exponent here is 1. So this is a to the 1 over, the index of the radical is 4. So remember, the index goes to the bottom. So that's a to the 1/4. Now on this one, remember, the understood index is 2. If you have a square root, you don't write the little 2, but it's inferred that it means 2. So I'm going to say, okay, so that's e to the 1/2 power. Now on this one, I'm going to have b. The power part's 2, so that's in the top part of the fraction. The index of the radical is 7, so that's in the bottom part of the radical. Now on this next one, look at 3 and 4. I can write these interchangeably. So for instance, I know that this is the same thing as the cube root of c squared. I also know that this is the same thing as the 7th root of b all squared. So your exponent can go inside under the radical, or it can go outside the parentheses, but regardless of where your exponent is, you deal with it the same way. So the exponent part is 2, either way I write this. So it's the top part of the fractional exponent. The index of the radical is 3. Oh, look at this one. I've got super duper. Now there's different ways you can do this, guys. I could go ahead, for instance, and say, let me make the inside d to the 3/9. And then I've still got to the 5th power. Okay? Well, that would be d to the 1/3, because 3 over 9 reduces all to the 5th power. And then I could say, well, power to a power you multiply, and I know 1/3 times 5 is 5/3. So this is going to be d to the 5/3. Sorry, I ran out of room. Now the other way to do this would be to say, well, wait a minute, I could do power to a power right off the bat. So I could say, well, 3 to the 5th, d to the 3rd to the 5th is d to the 15th. And you could do your power to a power right then and there. Then you would have d to the 15 over 9. All right? 15 and 9 both are divisible by 3. So if you divide by 3, divide by 3, you're also going to get d to the 5/3. So again, you've got options on these. And it might be that one time you see it one way and another time you see it another. Now, these are fun because a lot of people will go, you are crazy if you think I can do the 100th root of 81 or I can do 81 to the 25th power. You're right, I can't do either one in my head. But sometimes if you'll take it from radical form to exponent form, you can go, oh, good grief. You're trying to make it look worse than it is, Miss Porter. So 81, this is to the 25 over 100 power. Oh, good grief. 25 over 100 is 1/4. So now we're back to saying that's just the 4th root of 81. That's not a hard problem. The 4th root of 81 is 3. But I am going to be actively trying to see if you recognize when I'm giving you easy stuff. So I promise, if you know your rules, there's always something that makes the problem suddenly feel easy. So on 7, let's do the same thing. Do you see you can write it as 100 to the 4/8 power? And of course that reduces to 1/2. All right. Oh, well, of course that means the square root of 100. Oh, so it suddenly is recognizable. Now it feels easy. It's the square root of 100 is 10. All right, so again, take a look at this one. You've got your two choices. I can say, on one option, I could say, well, I can say that's 5 to the 3. Remember, this is an understood 2. So 5 to the 3/2 power, all to the 4th. Wait a minute. Oh yeah, power to a power. Remember that when you do power to a power, multiply 3 over 2 by 4 over 1, so you can easily see that the 2 divides into the 4. Oh, that's 5 to the 6th. Okay. 5 to the 6th. Now let me come back to that because we might have to do a little work on that. I think we know 5 to the 4th. I don't think we know 5 to the 6th, but we could probably figure it out if we had to. Now the other way to look at this is, remember, I'm going to look at it with a pen. It's usually easier. You could say, well, let me first look at it as the square root of 5 to the 12th, because I see that 5 to the 3rd to the 4th is multiply powers 5 to the 12th. Now I can say this is 5 to the 12 halves, because remember the understood index of your radical is 2. So there's 5 to the 6th that way. So you get 5 to the 6th regardless. Now wait a minute. If you're trying to figure it out, like you can make 5 to the 6th, and you can do this on either one. I'll just do it on one of them. Like the highest power of 5 I know is 5 to the 4th. And I know that I could rewrite 5 to the 6th as 5 to the 4th times 5 squared. 5 to the 4th is 625. And then 5 squared is 25. And then if I needed to, I could do 625 times 25 with old school elementary multiplication. I generally won't give you that big a number. I just did use my calculator just now. I generally won't give you that big a number on quizzes and things because I can find out if you know your rules with radicals and with powers without giving you like extraordinarily large numbers. So don't worry too much about that. All right, so now we're going to go back and really apply our rules from yesterday. So remember, yesterday we had rules like x to the a times x to the b means x to the a plus b. Or x to the c over x to the d means x to the c minus d. Or x to the e all to the f power means x to the e times f. We did those rules, plus the rules where you know that x to the 0 is 1. And we've already reviewed the rules with negative exponents earlier. So all these rules that we did yesterday with integers, we're going to do today, except we're going to have fractional exponents. So we've got quite a bit of fraction action coming our way. So if it were me on this first one, I would say, well, I've got to do power. I'm going to try to do that without moving my problem around. How about that? I've got to do power to a power. So again, 1/3 times 2 over 1 is just 2 over 3. You multiply straight across the top, straight across the bottom if nothing reduces out. So I've got a to the 2 over 3 power times a to the negative 1/9 power. Okay, well now what I've got to do is add my exponents. So all this scratch work I'm doing and then I'm erasing, you could literally have a sheet of my scratch paper out and do all your scratch work on a sheet of paper that you're just going to toss. Okay, you don't have to put all the scratch work on your good paper. But I know the rule here is that I have to add exponents, because remember, if it had just been 4 b to the 4th times b to the 3rd, you would say, okay, yeah, 4 plus 3 is 7. So I'm still just adding. So guys, if I say what is 2/3 plus 1/9 or minus 1/9, however you want to say it. Well, the common denominator is 9, so I've got to multiply the first fraction by 3 over 3. So now I can write the first fraction as 6 over 9. The second fraction is 1 over 9, so when I subtract, I get 5/9. So I'm going to say a to the 5/9, and I'm done. Now, I know I'm done because it says take it to exponent form. FYI, if it had said, now I want to write your final answer in radical form, you would have said then the final answer would be the 9th root of a to the 5th. So both answers would be correct, like both answers are right work. It depends on how the problem is worded to know if you end in exponent form or radical form, because it could be either one. But since this one said exponent form, we're going to leave it right here and we're going to move on. All right, so again, on number 2, you've got various ways of doing this. I kind of like saying b to the 5 to the 2 is b to the 10th. So let me rewrite this first part as the 4th root of b to the 10th. And then I'm going to write that as b to the 10 fourths. And then I'm going to write that as b to the 5 halves. So I'm kind of working on one part at a time. Now, the second one I'm going to write as b to the 2 sixths. Oh, that's b to the 1/3. All right, so now what I've got to do is add exponents. So here's my scratch work. 5 halves plus 1/3. Let's say my common denominator would be 6. So I need to multiply the first one by 3 over 3, so I get 15 over 6. And the second one by 2 over 2, so I get 2 over 6. So that's going to be 17 over 6. And that's my exponent. Whoo, fraction action. Some of you probably are crazy about fractions, but you'll actually find that you get a whole lot better at them, and then you won't be as intimidated by them anymore. Now, on the next problem, there's lots of ways to do this. There are different ways that are very effective. Let me show you the way I think most of you will do it, and then I'll show you a second way that you can think through it. But I think most of you will say, let's do the inside first, and that means what you need to do is add fractions. So I'm going to say c to the 16/3 on the outside. So I'm trying to get the fraction that goes on the inside. So let me see, I've got 1/2 plus 3/4. I add exponents in order to multiply like bases. My common denominator is 4, so I need to multiply the first fraction by 2 over 2 and make the first fraction 2 over 4 plus 3 over 4. Okay, so I'm getting 5 over 4. Not where I wrote that. All right, so that scratch work's gone. So remember the scratch work I'm getting rid of? You can literally just use my scratch paper for that kind of thing, okay? So the next thing I see is power to a power means multiply powers. So I'm going to have to do 5/4 times 16/3. Ooh, I multiply straight across the top, straight across the bottom, unless I can reduce. So 4 goes into 16. So that's going to give me on the top 20 and on the bottom 3. Okay, so I've got it. It's going to be c to the 20/3 and the final answer. Let me get rid of that so I can write my final answer. And there you go. Okay. Now, there is another way you can do it. And this might be more confusing, so if you're afraid that me showing you an alternate way is going to make things worse for you, maybe fast forward the video like by 30 seconds. So I can break this up, this problem from the get-go, I can break it up into c to the 1/2 power, all to the 16/3, times c to the 3/4 power, all to the 16/3. And this isn't pretty, then I'm writing over the top of my old problem. So now on the first part, I have to multiply 1/2 times 16/3, which gives me 8/3. So that would be c to the 8/3. In the second part, I need to multiply 3/4 by 16/3. Well, you know what? That's going to give me 12/3, and you might go, well, but you can reduce that. I can, but remember, once I get to the c to the 8/3 times c to the 12/3, I have to add the exponents. So 8/3 plus 12/3 is 20/3 because I've already got a common denominator. That's why I didn't go ahead and add exponents, because I realized it might be more helpful if I didn't. Normally I would reduce though. So I've gotten rid of a little of my mess there. So otherwise, just do the dark blue method, okay? All right, we're almost there, guys. We're going to do some with letters, and then we're going to go back to trying to evaluate. So on number 4, it's a cube root divided by a square root. Now, I can multiply any pair of square roots. I can multiply any pair of cube roots. I can divide any pair of square roots. I can divide any pair of cube roots. But I cannot multiply and divide when one's a square root and one's a cube root. So the way that you level the playing field here is to go to exponent form. So on the top, I've got d to the 1/3. On the bottom, I have d to the 9/2. Remember, the understood index on that bottom radical is 2. Oh, so remember, you need to subtract, and we typically take it to where the exponent is larger. So do you see that 9/2 on the bottom is larger than 1/3 on the top? So I'm going to move this thing to the bottom. Now remember, let me show you another problem just so you remember. If I had x to the 4th over x to the 11th, wouldn't you make that 1 over x to the 7th? Where you subtract and you take it down because the x to the 11th is bigger than the x to the 4th? We're going to do the same thing. So my scratch work here is I have to, instead of saying 11 minus 4 in the simple problem, I have to say 9/2 minus 1/3 in the not so simple problem. So common denominator is 6. Let me multiply that by 3 over 3 so I can get it 27 over 6. Let me multiply this by 2 over 2 so I can make it 2 over 6. And I'm getting 25/6. And then I'll have scratch work to erase. So it would be 25/6 on the bottom. We moved it to the bottom because the 9/2 was bigger on the bottom than the 1/3 was on the top. Okay, so now on number 5, this is one especially that it would be reasonable to ask you to do this in exponent form or in radical form. And without reading the directions, you would not know what the teacher expected. But I see again that it says go to exponent form, because this is also a good radical practice problem. Guys, if I look at this one, this is simply saying it's a to the 2 over 7 power. Because remember, the index of the radical goes on bottom. Times b now to the 3 over 7 power. Times c here to the negative 4 over 7 power. Because the root's always the 7th root of all of those individual pieces. And then d to the negative 14 over 7 power. So a to the 2/7 you can't do anything with. The fraction doesn't reduce. B to the 3/7, ditto. C to the negative 4/7 I'm going to put on the bottom as C to the 4/7. And then D to the negative 14/7 is D to the negative 2. So I'm not only going to make it 2, 14 over 7, 2, but I know since it's a negative exponent, I drop it to the bottom. So you get that weird fraction. So you have a fraction where the variables each have fractional exponents, except d squared. All right, so on number 6, it's like number 4. I can multiply any pair of square roots. I can multiply any pair of 4th roots. I can multiply any pair of 12th roots. But I can't multiply when my roots are not the same kind of root. So a square root and a 4th root aren't the same kind of root. Well, the way to get around this is to go to exponent form. So in the first part, the square root of e is e to the 1/2. Remember, the understood index is 2. On the next one, I've got e to the 3 over 4 power. On the next one, I've got e to the 5 over 12 power. And I know that what I need to do is multiply. Now remember, if I had x squared times x to the 5th times x to the 10th, would you not say that was x to the 17th? Because you would say, well, 2 plus 5 is 7, 7 plus 10 is 17. You're going to do the same thing here, guys. We're just going to add the exponents. It's just adding those exponents is a little oogier because of the fractions. You're going to get good at fractions, though. And you'll get to where you'll think, why did I used to be intimidated by fractions? All right, so here we go. I'll do step by step. Now, on the common denominator, 2, 4, and 12, I'll go into 12. So I need to multiply this by 6 over 6. So I get 6 over 12. On this one, I need to multiply by 3 over 3. So I get 9 over 12. And then on this one, I don't need to multiply by anything. 1 over 1. So just 5 twelfths. So 6 plus 5 is 11 plus 9 is 20 twelfths. Okay, 20 twelfths. Divide by 4, divide by 4. That's going to be 5 thirds. So your answer is e to the 5 thirds. And again, All this scratch work where you're working on adding and multiplying and subtracting fractions, it's scratch work. You can put it on an individual sheet of scratch paper and then just recycle it at the end of class. Or this would be a thing if you wanted to work with a marker on your desktop with a sock. You could do your scratch work in the desktop and just erase it when you're done. Okay, so 2 more pages. Let's have some fun. We are not only going to work with exponent form, we're going to evaluate, okay? So when I look at the first problem, I see, oh, it's like one of these problems. Number 1 is like, if I had something that was simpler, like x to the 5th over x to the 9th, and I know I would make it 1 over x to the 4th. It's one of those kinds of problems, guys. All right, so 2/3 is bigger than 1/6. That means I have to subtract the exponents to the bottom. So it's 25 to something. Now here's my scratch work. I've got to say 2/3 is bigger, so subtract 1/6 from it. The common denominator is 6, so let's make that first fraction 4/6 minus 1/6 is 3/6. 3/6 is 1/2. Oh, this is good. Now I'm going to say, oh, 25 to the 1/2 is square root of 25. It's starting to feel easier. So remember I told you if you're doing the right thing with your exponents, I promise you'll get to a point where you'll go, okay, this is no longer intimidating. It's starting to look familiar again. Now the second problem is power to a power. So remember, if I had x to the 4th to the 2nd power, you just say, yeah, that's x to the 8th. Power to a power, you multiply. So I'm going to do the same thing. So it's going to be 2 to something. So my scratch work would be I need to do 14/3 times 12/7. Oh, look, look, look. 3 goes into 12 4 times. 7 goes into 14 twice. So 2 times 4 is 8. Well, that's 2 then to the 8th. Oh, that's way better. Now, I still have some stuff to think through. Do you remember on the earlier problem we said, well, if 2 to the 6th is 64, then if I multiply that by another 2, I get 128. Well, if I multiply that by another 2, I get 256. So I can figure that out. It's not fun, maybe, to have to work with your powers without calculators, but it is doable. And the more you practice without calculators, the better you'll get. Now, problem number 3 is another problem where if I had like x to the 8th times x to the 9th, you would say, okay, that's x to the 17th because you just add exponents. So that's what I'm going to do. I'm going to say, okay, all right, I got to add 1/8 plus 5/8. Well, that's 6/8. Oh, that reduces to 3/4. Cool. So this is 16 to the 3/4 power. But guys, I'm saying evaluate. So I'm saying get it to be as simple a number as you can. Well, to do that, you need to say the 4th root of 16 to the 3rd. Miss Porter, you told us we didn't have to know 16 to the 3rd by heart. That's right. Remember, you can do 16 to the 3rd first, or you can do the 4th root of 16 first. I'm going to go small before I go large in general. So the 4th root of the 16 part's 2. Now do to the 3rd part. 2 to the 3rd is manageable, guys. All right, the last problem is like, or problem number 4 is like problem number 3. It's one where you just have to add the exponents. So it's going to be 49 to something. So here I go, scratch work. 1/5 plus 3/10. Multiply this one by 2 over 2 so you can get your common denominator of 10. Oh, look, look, look. Look at this. This isn't bad, is it? So I'm getting 5/10, which is 1/2. Now you should start to say, okay, I'm seeing light at the end of the tunnel on this one. I see what's going on. Are you good that that is the square root of 49? Hit it with 7 and go, woohoo, we did it. All right, one more page. This has been a long guy, but you've hung in there well. I have a feeling that you've done a really good job. Okay, so again, on number 5, there's 2 ways to do it. Let's do the inside first because something tells me that that might overall be the way that makes the most sense to you. So let's do the inside. Well, that's another situation where you're going to have to add the exponents, and we'll get to the 3/7 part in the outside soon enough. So on the inside, you got to say 1/3 plus 4/9. The common denominator is 9, so I'm going to multiply the first fraction by 3/3. So I can write it as 3/9 plus 4/9 is 7/9. Okay, you may not see it yet, but things are about to get better for you, all right? Because now I've got 8 to a power, so that means what I'm supposed to do is multiply my powers. So I've got 7/9 times 3/7. Woohoo! The 7's go. And 3 goes into 9 3 times. So I would have to say that's 8 to the 1/3 power. Light at the end of the tunnel. It just got easier. That's cube root of 8. And guys, what is it? What is it? Correct. 2. Good job for you. All right, so on the last one, again, you might be going, you're not allowed to do that, Miss Porter. I can multiply 2 cube roots. I can multiply 2 sixth roots, but I cannot multiply a cube root by a sixth root. That's correct. You are confined by the rules of radicals. However, we are less confined if we go to exponent form. Because now I know we're back to, oh yeah, add exponents. So the common denominator is 6, so let's make this first fraction 2/6 plus 1/6. That's 3, oh good, 3/6. So what's the answer, guys? What's the answer? Can you beat me? Can you beat me? Can you do the next step? What do you get? Give me a woohoo if you got it. All right, last problem. I bet you're worn out, aren't you? Now on this one, you need to recognize that the 32 on the top is 32 to the first. But I'm going to make a suggestion to you. Since the bottom is written as 32 to the 4/5, I would usually say, then let's write my 1 more constructively. So I would say write my 1, my understood power of 1 is 5/5. So again, let me remind you where we are. If I had x to the 8th over x to the 6th, you would say that's x squared, because you would have subtracted exponents to the top, because the 8 was bigger than the 6th. So I'm going to do that. I'm going to subtract exponents to the top. So wouldn't you say 5/5 technically minus 4/5? Isn't that what you're technically doing, even if you don't write that step out? So I'm getting 32 to the 5 minus 4 is 1/5. 5th root of 32, and that is 2. And you did it. All right, good job. I hope that this went well. Certainly be prepared to ask me thousands of questions if that's what it takes to make sure you've got this down pat when I see you again.